Hey everyone, and a very warm welcome back to Conceptual Maths. I'm so excited you're here today because we're going to unlock a concept that trips up so many students, but honestly, it's incredibly satisfying once you can visualize it. In this explainer, we're diving straight into some Oxford Mathematics Class 5 material to master comparing and ordering decimals. By the end of our time together, you'll be able to look at literally any tricky decimal number and confidently know exactly where it belongs. So here's our quick roadmap for today. We'll start with number 1, the golden rule. Then we'll cover the placeholder zero trick, using greater and less signs, ordering like a pro, and finally a final challenge just for you.
All right, let's jump right into part 1, the golden rule.
Okay, everything we do today is built on this one single foundation. It is absolutely crucial. When we compare decimals, we always start comparing from the far left side and move to the right. We follow a really strict order. Step 1, we check the ones. Step 2, we move past the decimal point to the tenths. Step 3 goes to the hundredths, and step 4 takes us to the thousandths. The golden rule here is at the very moment you spot a difference in a column, the comparison stops immediately. You have your answer. Watch how perfectly this rule works when we stack the numbers vertically. Let's compare 0.55 and 0.6. Just guide your eyes right down those columns. First, look at the ones column. Well, they're both identical zeros, no difference there, so we move to the right. Next is the tenths column. Look closely. In the top row, we've got a 5, and in the bottom row, we have a 6. Ding, ding, ding! We found a difference, so we stop right here. Since 6/10 is clearly greater than 5/10, we instantly know that 0.6 is greater than 0.55. It's completely foolproof. Moving right along to part 2, the placeholder zero trick. Prepare yourselves, because this is going to be the big aha moment of the lesson. We're going to introduce a little magic trick that makes confusing, mismatched numbers incredibly simple. You know, sometimes decimals try to trick you by having different lengths. Look at 3.68. It stops at the hundredths place. But here's the secret. Adding a 0 to the very end of a decimal doesn't change its value at all. It just acts as a perfect placeholder. So 3.68 gracefully becomes 3.680. Same exact value, but now it reaches all the way to the thousands place. And this brilliantly illustrates why that trick is so powerful. Let's say we need to compare 3.678 with our previous number, 3.68. On their own, they look kind of messy. But when we use our placeholder 0 to turn 3.68 into 3.680 and stack them vertically in their dedicated columns, wow, look at that. The ones are the same, both 3. The tenths are the same, both 6. But when you look at the whole decimal portion, comparing 678 thousandths to 680 thousandths makes it instantly obvious. 678 is smaller. Therefore, 3.678 is less than 3.68. Visualizing it just changes everything, doesn't it? Now for part 3, using greater and less signs. It's time for a snappy, interactive, rapid-fire session to test out those newly acquired visual skills. Let's see what you've learned. Here's your first question. 0.58 compared to 0.6. Which sign belongs in the middle? I'll give you a quick second to think about it. Okay, so if you're mentally running through the columns, you know the ones are both 0. So your brain should immediately jump to the tenths column. In the first number, we have a 5. In the second number, we have a 6. And boom, 0.58 is less than 0.6. Just applying that left to right place value rule gave us the solution in a fraction of a second. Let's step it up with a slightly harder example. 0.456 compared to 0.465. Let's trace it together. Ones, both 0. Tenths, both are 4. So we have to look past the tenths and check the next column to the right, which is the hundredths place. Look at the hundredths digit in both numbers. We have a 5 and we have a 6. Exactly! Since 5 is smaller than 6, 0.456 is absolutely less than 0.465. Look at you go! Your math intuition is growing by the minute. Okay, time to really level up. Part 4, ordering like a pro. Think of this as the final boss of our explainer. We're going to arrange multiple numbers of completely varying lengths. Here's our first real challenge. We need to identify the absolute largest, greatest number from this jumbled list of decimals, 0.971, 0.179, and 0.719. If you just look at them side by side, it can definitely make your head spin a little bit. But let's see how this builds when we use our visual tools. We take those 3 numbers and stack them perfectly by their place values. All the ones are 0. So following our golden rule, we drop straight down the tenths column. We see a 9, a 1, and a 7. Well, 9 is clearly the biggest number there, so the comparison stops. We don't even need to look at the rest of the numbers. 0.971 is our undisputed winner. Now let's try a really tricky decreasing order problem. Decreasing means going from the absolute largest down to the smallest. Our numbers are 5, 3.02, 5.014, and 5.023. These numbers look completely mismatched in length. We've got a whole number, a number ending in hundredths, and two numbers ending in thousandths. Honestly, it looks like chaos. But watch what happens when we use our placeholder 0 trick. We turn that naked 5 into 5.000. We turn 3.02 into 3.020. And suddenly, we effortlessly organize this chaos into a clean, easy-to-read vertical stack for flawless comparison. You can scan down the ones column and see 3 5s and 1 3. The 3 is clearly the smallest. Then amongst the 5s, scan the tenths, all 0. Scan the hundredths. We have a 0, a 1, and a 2. Following those columns reveals our final, beautifully arranged sequence. 5.023 is greater than 5.014, which is greater than 5, which is greater than 3.02. There's something incredibly satisfying about turning a messy list into a perfect logical sequence, isn't there? Let's pivot to increasing order, from smallest to greatest. This is our final and most complex set of jumbled decimals to organize: 2.57, 2.6, 2.583, and 2.538. At a quick glance, that 2.6 looks pretty small because it's so short, right? It only has 2 digits. Well, let's not fall for that trap. We stack the numbers vertically once more, filling in those vital placeholder zeros. 2.6 becomes 2.600. 2.57 becomes 2.570. Now, scanning the columns, the ones are all 2. The tenths are mostly 5s, but wait, look at the 2.600. It has a 6 in the tenths place, proving that 2.60 is actually the absolute largest number in the pack, despite looking artificially short at first glance. By comparing the remaining digits in the hundredths and thousandths columns, we can successfully complete the sequence. 2.538 is less than 2.57, which is less than 2.583, which is less than 2.6. If you followed along with that logic, you have completely mastered the core of this lesson. And that brings us to part 5, the final challenge. We've covered a lot of ground today. We learned to read left to right, discovered the magic of placeholder zeros, and practiced stacking varying numbers to make things easy. Now, I'm leaving you with a tough homework challenge to solve on your own. Arrange these 3 tricky decimals in decreasing order: 7.09, 7.9, and 7.099. Take a moment to work it out. You've totally mastered this, but just to leave you with a provocative thought, what happens when we need to compare negative decimals or when fractions enter the mix? The rules might just flip completely upside down. Until next time, keep exploring and happy learning.
Thanks for watching. Bye, students. Don't forget to subscribe for more math fun videos. See you in the next lesson.